EIGRP, that is an interior gateway protocol suited for many different topologies and media. So in a well-designed network, guys, EIGRP scales well and provides extremely quick convergence times with minimal network traffic. It was Cisco proprietary protocol until 2013, but it is industry standard now. EIGRP uses the dual algorithm to find the best path and make equal as well as the unequal load balancing, and can provide summarization for each router and each interface. We have three different types of tables that we use in EIGRP terminology, and they are the neighbor table, topology table, and the routing table. So the neighbor table, it includes all neighbors that is directly connected to router using EIGRP. Topology table includes successor, feasible successor, and all other paths going to the target network. On the other hand, routing table includes only the best paths for the target network. We have mainly 5 packet types in EIGRP, and they are hello, update, query, reply, and egg. Hello, same like in OSPF, it is used to discover the routers which are using EIGRP, but this time it is sent to 224.00.10 each 5 seconds for IPv4, and also FF02 : A each 5 seconds again in IPv6 networks. The update packets are sent if only there is a change in the network topology. Query is the packet that asks for if any network occurs on the neighbor or not. We have the reply packet, that is the answer of the query packet, and we have the egg packet, which acknowledges the query, update, and reply packets. EIGRP uses a composite metric to determine the best path to a destination. The metric calculation is based on several parameters known as K values, which can be adjusted to influence routing decisions. These K values are only numbers to scale numbers in the metric calculation. So K1 is the bandwidth, K2 is the load, K3 delay, K4 reliability, and K5 is the MTU. By default, we have this complicated formula to calculate the EIGRP metric. As you can see in here, there are lots of parameters, but by default, again, K1, K3 is equal to 1, and K2, K4, K5 equals to 0, and the end result is 256 multiplied by lowest bandwidth plus all delays divided to delay in microseconds. That is how we calculate the metric value in the EIGRP. By the way, pay attention that bandwidth should be 10⁻⁷ divided by the bandwidth. So the dual algorithm, it is diffusing update algorithm, is the route calculation algorithm used by EIGRP. So this algorithm really provides a fast convergence for EIGRP protocol. When it comes to the key features of the dual, we have some terms that we need to know. The first term is feasible distance. That refers to the lowest metric for the particular destination. And we have the value of advertised distance. That refers to the metric to a destination as advertised by a neighboring router only. And we have successor as well as the feasible successor terms. Successor is the primary route that is used for reaching to destination, and feasible successor is the next hop router that is guaranteed not to be part of a routing loop for a particular destination. So how we verify it? This condition is verified by testing the feasible condition. So AD should be smaller than FD of the successor. There is an example on the screen. Okay, so from router 1, if I would like to reach 1041.20 network, which path should I use if I'm using the EIGRP? That is the question. Okay, so there are mainly two paths, right? The first one is here and the second one is here. How I am calculating the best path for EIGRP using dual algorithm is like this. Okay, for this path, feasible distance is 300 plus 10. It is 310. Okay, that is my FD. On the other hand, the AD advertised distance is just 10 for the same path. Remember, 10 is the AD and AD is what my neighbor router is telling me. So router 3 is saying, hey, I have reachability to this network and my value to reach there is only 10. Okay, and this is advertised value. The advertised value is 10. FD is 310. Okay, when it comes to the path on the right side, I'm able to see that my FD this time is 410 and advertised distance that is again 10 for the path on the right side. Okay, so the FD for left path is 310, for right path is 410. So this is the primary path, okay? Whichever has the lower FD value from the paths, that is gonna be the primary path to reach to the below network. In this case, this is this path. So let's have a look to the EIGRP routing table entries. Okay, so I'm able to see the EIGRP routing table entries again by typing the show IP route. Okay, first of all, I am seeing one letter in here that is D. Remember, in OSPF it was O and in EIGRP it is D. So D means I am reaching this network by the help of the EIGRP protocol. Okay, and then I have my successor. This is the successor. Okay, this is the next hop basically that I'm using, and we have this value. This is the feasible distance that we have seen before. Okay, and then we have the administrative distance of the EIGRP protocol, which is 90 by default. And how I am reaching this network 5555 is by using my Gig00 Ethernet. So that is how an EIGRP routing table entry looks like. When it comes to the topology table entry, remember, routing table includes the best paths. On the other hand, topology table, it includes the possible other paths to reach the destination, right? So how I'm seeing the topology table is by typing show IP EIGRP topology. Okay, and for example, let's have a look to this network. Okay, that is 192.168.5.0, and I have one successor, and FD feasible distance is 3072. And as per this topology table, I can reach to this network via 35.5 or 35.4, right? So The FD value is 3072 for this one and 4352 for the 34.4 router. Okay, so this one is the successor. Okay, because the feasible distance is smaller compared to the one in the below. Okay, but which one is the feasible successor? That is another question. The feasible successor is this one because it is matching the criteria, which is AD should be smaller than FD of the successor. What is the FD of the successor? It is 3072, as you can see. What is the AD for this one? That is 1792. Okay, these values, you could see the first value represents the FD, the second value represents the AD. Okay, what is the rule for becoming feasible successor? The AD should be smaller than successor's FD. Okay, the successor has an FD value of 3072, so that is why this router is the feasible successor when I am trying to reach this network. Okay, I hope it is clear. So this is how an EIGRP configuration really looks like. Okay, what I'm doing in the config mode, I'm typing router, EIGRP and the autonomous system number, which is 1 for this case. And I have my network commands again, same like in OSPF. But this network statement does not really specify a network to advertise in EIGRP, guys. Rather, it specifies a range of one or more IP addresses, and any interface with an IP address in that range is instructed to participate in the EIGRP routing process. This means, for example, if we want all interfaces on a router to participate in the same EIGRP routing process, we could give the command network 0000 to specify all possible IP addresses. And then we finally have again the same command as the passive interface and the passive interface that we don't want to send any hello packet. How we are verifying the EIGRP configuration? It is by using show IP protocols command. It will show you the autonomous system. It will show you the timers, maximum paths for that particular AS number and other bunch of other information as well. If you just want to verify your EIGRP neighbors, that is the command show IP EIGRP neighbors. It will show you the other routers running the EIGRP and formed a neighborship with that particular router. Also, again, we have our show IP route command output that we have reviewed already. And now let's have a look to the EIGRP IPv6 configuration. This is how it looks like. First of all, I type again IPv6 unicast routing and activate the IPv6 routing. Then I type IPv6 router, EIGRP and autonomous system number. In here, guys, there is one, something different, okay? So there is a router ID required for EIGRP version 6 configuration. Okay, that is very important. Don't forget it. Same like in OSPF version 2, we need to configure a router ID for IPv6 version of the EIGRP. Okay, and then I'm typing no shot and I'm exiting this. And then I'm entering my interface configuration, and then only thing I am typing is IPv6 EIGRP and the same autonomous system number. So the verification is again pretty much similar. That is show IP version 6 protocols this case. Show IP version 6 EIGRP neighbors is used to verify the neighbors, and show IP version 6 route is used to verify the IP version 6 route table for EIGRP. Alright, we are again coming the end of this session. Thank you so much for listening to me. And again, don't worry if you have any question marks, any concerns regarding the configuration steps, because I will do a lab session. Yeah, so don't worry. You will learn each and everything you need regarding the EIGRP configuration in our lab session, which is for EIGRP configuration. Okay, thank you so much for joining me once again, and have a great day ahead.